Okay, guys, later on this week in class, maybe as early as tomorrow, I'm going to do a little demonstration with Desmos and show you translating with quadratic functions again. But let's say I was to give you a worksheet like this, which may happen very soon. Let's just do, let's say, a couple of them, maybe the ones actually on the screen here. So what I hope you understand is that whenever the quadratics are positive, you know they're going to open up. So if we look at problem 2 right here, see that negative 1/2? I know that one's going to open down. In other words, it's going to look like that, right? Instead of opening up, it's going to open down. Okay? So hopefully we got that idea down. So let's follow through here. So that one opens down. The positive 4 means it opens up. The negative 1/3, both of those are negative 1/3. You know they open down. I have a positive 8 on both of these. They open up. The 2/5 is positive. It opens up. And a negative 2/5 is negative, so it opens down. Now, another thing we're going to talk about a little bit is amplitude. Okay? And since we already just looked at the signs, that negative 1/2 right there, guys, its amplitude is 1/2. In other words, instead of growing at a normal rate, it's going to grow a little bit wider and slower at half the rate. And that's what we refer to as the amplitude. Okay, so just remember the number in front of the parentheses is your amplitude. So the 4 right here, I hope you agree, means amplitude 4. And I think you get the idea. These two have an amplitude of 1/3. These two have an amplitude of 8. Both of these have the same amplitude. The difference is one of them is going down. The other one is going up, but their amplitudes are 2/5. Now, what about the vertex? Right? Well, remember, guys, if you look at all of these hopefully you recognize are vertex form. So in other words, whatever makes that right there 0, you see is a vertex. That's why we would say it's 2. And then notice the number at the end is your y value. And hence the name vertex form. You literally can look at the equation and see the vertex. So let's go with our number 2. Stay with me here, guys. I'm going to go 2, 3, 4, 5 again. What makes that 0 in there is a 5. The number at the end, negative 3. That is my vertex. The number right here is what makes it 0 is a negative 5. Be careful with your negatives. Again, that right there, the negative 3, completes the vertex. What happens when the number is missing? Well, that makes it simpler. The x-coordinate is 0. And of course, as you can see for both of these, the y-coordinate is positive 8. So 0, 8 is where their vertex is going to be. And hopefully you agree we can just complete the rest of these. I'm going to go back to black. These two have the same x-coordinate of positive 2. That makes it 0. This one, though, has a positive 8. This one has a negative 8. So they have different vertexes. Same x, but different y. And then the last two, as you can see with the plus 1s, that means negative 1 would make them 0. And they both have a negative 4. So they both actually have the same vertex. Okay, now the last column, guys, is just asking whether the vertex is a max or min. And I guess I'll just stick with black, if you don't mind. And so the idea is what makes it a minimum, you see, is if it opens up, then the vertex right there, everyone knows where the vertex is, that's going to be a minimum, right? So when it opens up, you know you have a minimum value. When it opens down, you have a max. And if you understand that, this is really simple. So as you can see, this one opens down, so therefore I know that vertex is going to look like this, and it's going to be a maximum. Okay? And just finishing up here, this one opens up, so it's a minimum. These two open down, that must mean they're maximums. These three open up, that means they're going to be minimums. And finally, that one opens down, that one's going to be a maximum. Oops, maximum there. I'm right on the corner of my screen there, so maximum. Okay, so let's put all this information together. We can do these two graphs in literally seconds, right guys? If you understand what we did in the table, we know right here 2 makes it 0. So therefore our vertex is going to be at 2, -4. Excuse me. We know not only is a vertex there, but we have an amplitude of 1/2. So guys, normally, and we could actually make a table, actually. That would be probably a good idea so you could see the 1/2 in action. But basically, for, let's go ahead and make a table. I'm starting to mumble, guys. Sorry, I'm a little tired here. But anyway, so we know 2 is, again, -4. And let's go ahead and do 1 and 0 and 3 and 4. And actually, we'll just do a couple points here. Let's do 0, for instance. 0 minus 2 squared is 4. Half of 4 is 2. -8. By symmetry, I know that's -8. It looks like I'm going to be a little bit off the screen, but 0 is going to be at -8 right there. And 4 is going to be at -8 right there. Now, I want to remind you guys, on the final, it's multiple choice, so all you need is 2 to 3 really good points, especially if you got the vertex and you're done. Okay? And number 30, hopefully you agree with a x plus 1. If I'm going to make a table, then erase it. Or actually, I'll just put it here to the side. And actually, I better put it to the other side, right? Because my middle is going to be at -1,5 right there. So I'm gonna make a little table to the side here, guys. Didn't leave myself much room, did I? So we know -1 is 5. Always put the vertex in the middle of the table. How about we just do 0 and -2? Because that's all you need on the final, just 2 or 3 good points. If we plug in 0, we know 0 plus 1 is 1, squared is 1, times -2. Remember, guys, you also can use your calculator and type it in. -2 plus 5 is 3. By symmetry, -2 is 3. We're ready to go here. 0, 3. We already have -1, 5. We have -2, 3 there. There is my graph.